Welcome to this video on converting between quadratic forms, day 2. Today we're going to focus on converting from vertex form from standard form and to intercept form from standard form. So you're going to need Desmos for us to convert to vertex form. What's important to remember is for our vertex form, we need, here's our general form, we need to know an A value, the X value of the vertex, and the Y value of the vertex. With those three numbers, we can write our standard form in vertex form. So we're lucky in standard form, this A value that's already there, this is a 1 because there's no number there, that's the same. The A value will remain the A value. So if it's 1 in standard form, it will also be 1 in vertex form. What I need now is I need the vertex. So pause the video and put this equation into Desmos and get the vertex out. Come back once you have finished. So here we have our equation in Desmos, and when I come look, I see that my vertex is -3, 2. So I'm going to come over here and write -3, 2. That's all I need to be able to plug this in to be in vertex form. So we're going to take this equation A. Well, A is 1. You don't need to write an understood 1. If it makes you feel better, you can write the 1 there. It's not going to change anything. Then we have X minus the X value of the vertex. So X minus -3 becomes X plus 3. The sign's going to change every time you plug that X value in. Squared, and then this is plus K plus 2. That is our vertex form. So you need to find the A value and the vertex and plug them into the vertex form of the equation. So let's try it again. In our second problem, our A value is 4. You need to get a vertex, so go ahead and pause the video, put your equation into Desmos, and get your vertex out. Here we've put 4x squared minus 8x plus 5 into Desmos, and here's our graph with a vertex of 1, 1. So I'm going to write 1, 1. And then we're going to plug it into the vertex form like we did before. The A value is 4, so we're going to put the 4 out front first. Then it's X minus the X value of the vertex, which is a positive 1, so it becomes X minus 1 squared, plus the K value, which is the Y value of the vertex. So this is the vertex form of that standard form equation. All right, for this last one, let's find our A value, and then I want you to try the rest all on your own and then come back and check once you've plugged everything in to see how you're able to do. So our A value here is a little tricky. We cannot have that negative sign there. We have to remember that it's part of the next one. So we're going to say A is -1. You go find the vertex and plug it into the vertex form and come back to see how you did. Okay, the A value is -1. Your vertex should have been 5, 28. So when we plug it in, we should have gotten negative, parenthesis, X minus 5, close it, squared, plus 28. Alright, so hopefully you're getting the hang of that one. And we're going to go to a slightly more difficult one. We're going to convert our intercept form into standard form. Okay, in order to do this, our standard form into intercept form, we need to factor this is really what needs to happen. So let's do a quick review of the steps for factoring. First, you got to find a GCF. Always check for GCF first. The second step, remember you're going to take A times C, and whatever A times C equals, you're going to look for factors that multiply to it. We have to remember if you get a negative value when you multiply A times C, that means your factor signs are going to be opposite for each other. One will be positive, one will be negative. If you multiply A times C and you get a positive number, that means you're either going to be a positive factors or negative factors. And that, you have to look at the sign of the B value. So look at the sign of B to determine whether it's positive, or negative. Okay, you're going to take the factor pair, and our next step is we're going to substitute the factor pair in for the B value. And what that does is it creates 4 terms. Okay. Now, once we have the 4 terms, the last step, we call that grouping. You're going to split everything in half and GCF. So I'm going to show you how to do that. Okay, so that's the overall, it's just an overview of what it takes to factor. So first step is always check for GCF. So let's do that with number 4. Number 4, all of these terms have a 2 in common. So I want to take the 2 out first. So we have 2, then we're going to write what's left over. The 2's will cancel to a 1, leaving just the x squared. Negative 14 divided by 2 is negative 7, and the x cannot cancel, so it comes down. And then we have positive 12 divided by positive 2 gives us a positive 6. Okay. Once we've done that, we need to have this GCF that we took out to be part of our answer. I'm going to take it and I'm going to write it down here so I don't forget about it. And I don't have to keep up with it along the way. And now I'm only going to focus on this trinomial. So the second step was A times C. Okay, so A is 1 here, so 1 times 6 gives us a positive 6. So that means our signs are either positive, positive, or negative, negative. So when you look at the B value, because it's negative, that means our signs are going to be negative. And we just look for the factor pairs of 6. So what multiplies to 6? 1 times 6 and 2 times 3. Those are our only options here, but we're looking for one of these pairs to give us a negative 7 if they both have a negative sign. That will only work right here with negative 1, negative 6. Okay, so that was all step 2 that we were talking about here. Now we're going to substitute the factors in for the B value, creating 4 terms. Okay, so we have x squared, then we're going to say minus 1x, minus 6x plus 6. These are equal because negative 7 is the same as negative 1 minus 6. Those are both equal to negative 7. And then the last step was grouping, and that's where we're going to split it in half and look for the GCF on each half. So on the left-hand side, both of these have an x in common. When I take the x out, one of the x's cancels on top, leaving an x behind. Both of those x's cancel to a 1, leaving just minus 1 there. Now, before we do the next step, we will always know if we do this correctly if when I write the other parenthesis, once I take out the GCF, our parentheses will match. So on the left here, these 2 terms have a negative 6 in common. So I bring down negative 6. The reason it's a 6 because of these 2 numbers, but it's negative because this sign right here is negative. So what I divide by has to be negative also. Negative 6 divided by negative 6 cancels to a positive 1, leaving just the x behind. Then you have positive 6 divided by negative 6, which gives you a negative 1. And see, we have our 2 parentheses are identical. That's how we know we are correct at this stage. Our final step is we have 2 terms. There's 4 times x minus 1, and the other term is negative 6 times x minus 1. They both have an x minus 1, which is the GCF. And when I take out the GCF, what is left behind is x minus 6. That's what goes in the other parenthesis. And this is your factored form. Okay, so we factored it, and that's the same as intercept form. Factored form and intercept form are the same. This graph crosses the x-axis where x is 1 and where x is 6. Let's try this again for number 5. Remember, your first step is always to check for GCF. So when I take a look, I notice that both of these have a 3 and an x in common. Okay, that's the GCF. I'm going to take the GCF out. What is left behind when I do that? These 3's cancel to a 1, and one of those x's on top cancels, leaving 1 x behind. 21 divided by 3 is a positive 7, and the x's cancels to 1, so they are out of there. Now, I cannot go any further because nothing is squared anymore. Once you're down to x to the first, that's how you're going to know you're done. This is actually as far as we can take this. This is a GCF only problem. This is in factored form. It is done. The intercepts here, remember to find an intercept, you would take each factor and set it equal to 0. So this graph, we could put this in Desmos and take a look, but this graph will cross where x is 0 and where x is -7. All right, one last one. Check for GCF. When I look, there is no GCF, but this does have a problem because we cannot factor if your A value is negative. So what we're actually going to take out is a -1. And when I divide by that negative, it changes everybody's sign. It's a 1, so the values don't change, just the sign. So that was -x squared, now it's +x squared. That was +x, so now it's -x. +12 becomes -12. Okay. From here, it is just like what we did on number 4. We're going to go to A times C. I'm going to bring that GCF down so it's part of my answer. A times C gives me -12. The sign is negative, so that means my signs of my factors will be 1 positive, 1 negative. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4. So one of these pairs needs to add to a -1 when one of them is positive and one of them is negative. And that actually happens if you have a +3 and a -4. So we're going to substitute those in. X squared plus 3x minus 4x minus 12. We just substituted this pair in with an x. We're going to group, meaning we're going to split this right down the middle. The left-hand side, they have an x in common. So if I take out an x, there's 1x remaining inside. These x cancels to 1, leaving the 3. On the right-hand side, I've got a negative number there. That tells me whatever I divide by has got to be a negative also. And I always check the smallest number. 4 does go into 12 evenly, so our GCF here will be -4. These cancel to a +1, leaving just our x. And then you have -12 divided by -4, which is +3. The GCF is x plus 3. What was left behind was x minus 4. And that's our factored form, our intercept form. Hopefully that was helpful to you. Let me know if you have any questions. See you in class.